राहुल ज्वाइन किए हैं. राहुल, Rahul, are you here?
Yes, sir.
You are not audible, Rahul.
Is it audible, sir?
Speak a bit louder.
Is it audible, sir?
Yeah. So, yes, Rahul. So, tell me something about yourself.
My name is Rahul Banerjee. I've completed
Be a
my
bit
class 10.
louder.
Is it audible, sir, now?
Yes.
My name is Rahul Banerjee. I've completed my class 10 and 12 from City, Jharkhand, and completed my electrical engineering from CVRM Global Ed.
From which college? College. I didn't get your
Which
college.
Rahul, what is your college?
CVRM Global University.
Okay. Where is this?
Bhubaneswar.
Okay. Continue. And that's it.
Continue your
Introduction.
And then I have achieved a 296 rank in GATE 2022.
Okay. And what are your hobbies?
Go on.
My hobbies are searching about the innovation, about new innovations, and that is going around the global, and also tutoring, online tutoring. Also, I have done. Also, my hobby.
Okay. So you have mentioned that you like to learn about some new innovations that are taking place, right?
Yeah.
So can you tell me what you have learned recently?
I've recently searched about the new AI that are that can helpful in making presentation or making in helpful in making presentations, Photoshop, or in creativity, like uh, various types of AI I have found in recently.
Can you name a few?
Its first one is Power Presentation.ai, and then Photoshop.ai. These are two major Photoshop I have recently found.
So did you do any internships or projects?
I have completed my major project in electric vehicle also.
Okay. And any internships?
Internship I have completed internship in SAIL Bokaro in 2018.
Okay.
It is vocational training.
Okay. So what did you learn there?
I learned about what are different types of machines that are used in industries like SAIL, or what are how they manufacture stills, what are different types of stills, how they go about maintenance of different generators, and how they care about when there is a fault in the distribution system around the industry.
So what were the ratings of the generators, sir?
I have maximum rating. I have seen that it is around 80 MVA that is used in oxygen plant, and it is used for producing oxygens in SAIL Bokaro.
Okay. So have you done any other internships other than say at SAIL Bokaro?
No, sir.
You have taken some trainings, I think. Right?
It is mandatory training inside our college that we have to go around to complete that semester.
Okay, so what were the trainings on?
It is mainly about PLC, SCADA, and DCS. What are the and upcoming Industry 4.0 also.
Okay, you have taken on PLC. What is a PLC?
It is programmable logical circuit in which we can design various
Is it
various
programmable logical circuit or logical controller?
logical circuit.
It's logical circuit. Are you sure?
Yes, sir.
Okay, and what is SCADA?
SCADA. SCADA is
What is the full form of
supervisor control and data acquisition system. Data acquisition system.
Okay. So, what is the language that you have learned in PLC?
That
On which
is,
station did you learn?
it is mainly about the ladder diagram that used in our PLC.
Okay, so
Ladder
you have learned in ladder logic.
ladder diagram.
And on which station? Like, what is the setup?
It is not about. It is inside our college also. It is inside our college, like
Yes.
a PLC 4 or PLC 5 DNAMD
Okay.
from
So,
Siemens.
if I ask you to design some logic, can you show it in ladder logic?
Yes,
Yes.
I can. I
Do you
can
have
draw it.
a pen and paper with you right now?
Yes, sir.
Can you draw? Are you sure? Can you draw if I ask you something?
Yes, sir.
Can you design a simple uh, NAND gate using ladder logic? Your paper isn't visible. I think it's because of the background. Show it in front of your face. Okay, okay, leave it. It's not visible. Okay, so what are your favorite subjects?
Our favorite subjects are electrical machine, power system, power electronics, and electrical measurement.
Electrical measurements. So, did you study about transducers and electrical measurements?
Or simply about that, what is transducer and what are the different types of transducer, like active transistor or a passive transistor.
Okay. So, which transducers are usually better, analog or digital?
We can say that digital transistor are better than analog transistor.
Reason?
Reason that we get a much accurate result in quick time.
Okay. So, what is Hall effect?
The Hall effect, this is a phenomena in which electric field is applied perpendicular to the magnetic field, and why, sir? I can't recall it now.
Have you heard of Hall effect transducer? No, it's okay. So can you tell me, do you know more about transducers or your knowledge is limited about it?
So, sir, only about the types of transistor, like active transistor or passive transistor. What is the different types of transistor?
Okay, so you know any examples of active transducers?
Active can be that are
Okay,
like stage gone. It can be
okay, it's okay, leave it. So you told me that your favorite subjects are power electronics, power systems, and electrical machines. So can you tell me some the conditions which are required for the voltage buildup in a DC shunt generator?
Yeah, the voltage buildup should be in the direction of the residual flux, so that the residual flux does not get cancelled out, and then the critical field resistance. The resistance should be less than the critical field resistance. The speed should be greater than critical speed, and the polarity should be the polarity should be same of that of residual magnetism.
Okay. Any other condition? And in the commutation process, what does an inductive kick mean? What is an inductive kick? Inductive kick. Have you heard of the term inductive kick? No. Have you heard of reactance voltage?
Yes, sir.
What is reactance voltage?
It is developed due to the current due to the current that flows from one segment to the other segment when commutator flows when the current flows when the commutator flows from one segment to another segment, the current that flows, it develops a EMF that is known as the reactance voltage.
Okay. So, okay, then Prince sir will ask you the remaining questions.
So in your introduction, you said that you worked on EV as a major project. So what EV, electric vehicle? Yeah.
We are mainly designed about the solar charging controller that will charge the electric vehicle in MATLAB.
Okay. Okay. So you are you have worked on controller basically, yeah?
Yeah.
Okay. So basically, can you tell me about that? Which type of controller you have used? Which type of controller which you have used in your for controlling your output or controlling your power, something like that?
Basically, our project objective was to control the current that was provided by the solar panel to control such that the battery, such that the charging time should be quick time. It may suppose that is in today's time that battery for the charging of a battery, it took mainly 4 to 6 hours but our project mainly concerned about the quick charging time that will charge the battery in 3 to 4 hours. That will help in reducing the heat generated by the battery.
But if you are generating, means if you are transmitting your power, or if you are charging your battery in 3 to 4 hours, and normal charger is also doing the same, then what is the difference?
We have controlled the current also by changing the solar.
Current control is available in every controller, because generally what happens, see, you know what about CC and CV mode of charging? CV. And already current controller is available in that, depending upon the SOC. So you have designed the controller, okay? So let me talk about the controller. So you have shown, or you have taken care of gain margin, phase margin in that controller.
I have designed that DC to DC boost converter that will help that the duty cycle change continuously, so that current that will we are controlling through the duty cycle of the boost converter.
Okay, means you haven't taken care of gain margin and phase margin. That means you haven't calculated all the things, right? Okay, it's okay. So you talked about the boost controller, I think so, yeah? So what is the ratio of, means V naught by Vi is greater than 1, less than 1, equal to 1? What is that?
V naught is greater than Vi.
Yeah, so V naught is greater than Vi. So you can draw the circuit diagram of boost converter.
Yeah.
And you can do one thing that, yeah, you can take a screenshot, and your laptop, you can share the screen and you can also show it to us.
Yeah, option of whiteboard.
Yeah, whiteboard is already available in Zoom, I think so. So you can use it, and you can also draw it on. You have pen tab?
No.
No, but with the help of mouse also, you can give me a brief idea that what is the boost converter, first of all.
There are no options of writing. Can I say verbally?
Yeah, sure. So what is the first in left side?
To the source side, it is connected to the inductor first.
Okay.
Then there is a switch in a vertical position. Then there is a diode. Then there is a capacitor. Then there is the output voltage.
Okay. So you have talked about the boost converter basically. Okay. So now over here, what is the average voltage across the inductor? You know what is the
Voltage,
formula for it? Sorry?
0. It is 0. Volt. Average voltage.
And can you please can you be able to derive that what is the critical resistance for which there is CCM and DCM mode? You know about it? So
Continuous conduction and discontinuous.
yeah, continuous conduction mode and discontinuous conduction mode. For that, you will get a particular value of resistance at which you can if you go higher than that resistance, then it will be a CCM or DCM. If your output
we can
if your
decide
output
also, we can also decide what the inductor value also.
yeah, but I'm talking about the resistance right now. So if we consider the resistance, okay, so we have critical resistance value, let's say. Now, if you go higher than that critical resistance, then you have CCM condition or DCM condition.
I need to
this
derive.
is just an oral question. For derivation, you will for boundary condition, you can design a particular value of resistance. Okay, if for the all condition remain same, if you go for higher resistance than the critical resistance, then the circuit will be in CCM mode or DCM mode. For this, you don't require any derivation.
We can derive the formula of L critical also. Then we can say from that formula that L critical.
Let's say the L is fixed for a particular condition. Okay, source value is fixed, L is fixed, switching frequency and the duty is fixed. All values are fixed. Capacitance value is fixed. Now only thing variable is resistance. So for this, you have calculated what is the critical resistance for which you get the boundary conditions, and if you change your resistance, then you can get CCM or DCM. So now you have to let me know that if we go higher than the critical value of that resistance, then it will remain in CCM mode or DCM or boundary condition, or you can means if we vary the resistance, so is it affect our CCM mode or DCM mode, or it will remain in the boundary condition?
Duty cycle will change. So obviously,
I also makes the duty constant. It is an open loop system. So if we change the resistance, so it will affect your means you get for boundary condition you have calculated the resistance, that is the critical resistance. Now, if you go for the higher value of that resistance, so the circuit will remain in CCM mode or DC mode. You know about it?
And we need to.
Yeah, no, derivation is not required in this. It is an oral question. Okay, so okay, let's say if we jump to the power electronic side itself. So what is the basic difference between IGBT and MOSFET?
IGBT is derived from the MOSFET, both from the MOSFET and the BGT, both conditions. IGBT provides that during the conduction time, the switching losses are less. The MOSFET that provides that during at the time of starting, the conduction losses are more in MOSFET, and that is negligible in IGBT.
Okay. And what about the frequency? Let's say I have to go for the higher frequency switching. So will I use IGBT or MOSFET?
MOSFET.
Okay. And what about IGBT? Means in what applications we can use IGBT? Means for example, I'll give you IGBT. So you'll use in which applications? Like for what reasons you will use your IGBT?
In three-phase inverters we can use.
Three-phase inverters are variable rating. Okay, so you can use IGBT and MOSFET as per your as per your power rating and switching frequency. But for what frequency or what power or what for your on means on state resistance, for what value of it will use IGBT.
For
Means
higher
there are particular
frequency, more than around more than 5 kilohertz, we can use MOSFET.
for means you are using IGBT for less than 5 kilohertz, right? Okay.
Yeah.
But why will you use IGBT? You can also use MOSFET with less than 5 kilohertz. So what is the reason that you are using IGBT for lower frequencies?
That conduction losses at around all the conduction losses that will happen in the operation will be less in IGBT.
Okay. And does IGBT have any parasitic resistance diode?
Yes.
IGBT have that diode?
No, MOSFET has.
So, and also if we talk about now, you are also comfortable in machine, as you said, true? So let's say I'll give you two types of motor, like DC series motor and DC shunt motor. And in a particular applications, like any traction motion, like locomotives, means trains which we are using. So it is in steady state, okay, first of all. For starting it, we require higher torque. So which motor will you use? DC series motor or DC? Why it is
series.
so?
Because torque is directly goes to square of current.
Okay. I thought you will not able to write it out. Otherwise, I can also
Torque is directly proportional to phi into IA, and in series connection, phi is directly proportional to the armature current. So it becomes phi IA into IA. So torque is directly proportional to IA square.
Yeah. So small doubt which I can raise right now over here is that you can tell. Let me know that if you also know one equation, E equal to K phi omega.
Yeah.
And E equal to K phi N. Yeah. In both of this equation, which one is correct?
E equal to K phi omega is correct, but we can also use K phi N also.
So if for using K phi N, you have to use K dash, okay?
Because E equal to phi Z and phi 16 to P by S. So phi Z by 16 to P by A is always constant. So we can replace it by K. So E is equal to K phi N. So we can also use K phi N, but in general process E is equal to K phi omega.
Okay. So
For motor constant for motor constant for the understanding better applications of motors, we can use E equal to K phi omega.
Okay. And last question from my side. So basically, if we talk about the DC machine only, so can you please tell me what is a universal motor? You have any idea about universal motor?
Yeah. Universal motor can run both in DC as well as in AC, because the connections it is generally a shunt machine, and we can apply both DC and AC. It is used in grinding machines that you are using, and also drilling machine also we are using.
Okay. So you said that it is a shunt machine, right?
I'm not also, but not sure about it. It's about the connections, but universal run both in AC as well as
it is basically DC series motor. So can you please tell me that how it will generate a unidirectional torque? Because in one in positive half we are giving the positive current, and in the negative half cycle we are giving the negative current. So how it will rotate in particular one direction? Because you know that T equal to K phi omega, K phi IA. So I is directly proportional to torque. So if we give the positive current, so torque will be positive, and if we give negative current, then torque will be negative. But why over here it is moving in a particular direction?
maybe we can relate about the generator action and motor action in machines. We can say that.
No, it's not that. It's okay. I will hand it over to Shailesh.
Okay, Rahul, can you tell me one thing? Why do you want to join BARC?
Basically, there is a transparency of about a job profile and transparency of the growth, and indirectly or directly I can serve my nation.
Okay, but there are multiple other ways to serve the nation, and there are other organizations or which are very transparent. What is that is particular to BARC that excites you to join BARC and become a scientist here?
Basically, basically doing thinking.
Okay, so one simple question with this Alan. Do you know the working of a nuclear power station? Simple working of a nuclear reactor or in a nuclear power plant.
But what are the components used, like what are the, like a nuclear reactor? In we have moderator. We use heavy water to control the mechanism of fission and fusion, and we also use moderator as a dietary heavy water. Uh, Although that's all.
Okay. So, okay then, uh, we'll end up this interview. And do you have anything to say, Prince?
No, no, it's okay.
Okay. So we'll give you the feedback. Shall we give it right now? Okay. So yeah, Prince, you tell, then I'll tell him the feedback.
Actually, see, first of all, you can also give more basics, means you can also focus on more on basic in power electronics, because sometimes when you start with EV, when you say that in EV I have worked, so basically if you just specify the controller, then you must know all the things about the controller, because while you are designing the controller, it has 13 steps. So from starting to ending, you have to, if you don't know everything, then it's okay, but you have to have a big idea.
Basically, I have controlled the resistance of the solar.
See, if you're controlling the resistance solar output, okay, and you're charging your EV, then EV have two types of mode. It is CC mode, CC mode and CE mode. CC means constant voltage. Sorry, CC means constant current, and CE means constant voltage. Or it depends upon the SOC, state of charge of that battery. While it's charging from 0 to 80% of its SOC, and it will work on constant current or voltage. You know about it.
I need to get more detail about my project.
Okay, so it depends upon the that SOC, that if the SOC is higher than a particular limit, that is 80%, then the CC and CE mode changes. Okay, and based on it, your controller will be defined. So whenever you are designing your controller, and because you are charging your battery, so 0 to 80% of your SOC CC mode will be there, and 80 to 100% of your SOC CV mode is there. Okay, so based on this, you must know the big idea, or means overall idea, that what about the controllers, what you are controlling. If you are controlling your resistance according to your battery, then you must know the state of the battery, means what is the state. Accordingly, you will change your battery. Because in simulation, what we are doing, we are considering only at a particular moment of your battery.
But in simulation, the only the result about a graph about the SOC in the result is given.
Okay, SOC changes or not over there?
It is around
Because I have worked in MATLAB, so
I have first
So,
for
standard-
0 to 0.1 second, it is changing from 0 to 100%, and it is constant. So that graph shows.
okay, because generally when we are using a component as a battery, then we have to also feed your SOC. So based on the SOC, you can design a controller. It's okay. And then if we talk about the, see, when you jump on the machines now, then you must know. See, over here we don't have that privilege to see what you are writing. But if we talked about the derivations and all, then you must be confident in that. Okay, first of all. And whenever you don't know about anything, then please let us please let your other besides know, means interview knows that you don't know about it. Okay, if you're just mugging it up, or you're just giving a rough idea that yeah, it may be this or that, and it will give a negative impression. Right now, let's say when we discuss about the universal motor, and then you at that moment say that it is a decision motor first, and you don't say that yeah, it is basically, I really don't know about it, but it can be decision. You can talk about it, but starting you said that it is decision motor and it will have this and that. So my next question should be like, if it is a decision motor and torque equation is T is directly proportional to current, then why it is unidirectional, not in the both direction. Okay, so in this way you can be also get caught in between. So if you're not confident in that, then please let your interviewer know that it might be this or that. Okay. Shailesh, you can take hand over.
Okay, Rahul, regarding this, I see that you know the subject topics, you know the content, but there should be some more clarity in your expression, like how you express it in words. Like when I asked you some definitions or some conditions, follow, like you have answered voltage build-up conditions, all your conditions were correct, but they should be in a proper order and make it into a proper statement. Think for like 10 seconds in your mind and then start replying. Okay.